Sketch a graph on a rectangular plane to help draw the polar graph for r equals 3 sine theta. All right, so let's take this, and in a previous video I made a table. I'm not going to make a table. I'm just going to make a regular old trig graph based off of this information. Now, there's two things that I notice. There's a 1, which translates everything up 1. The amplitude is 3. So knowing how to graph trig functions, I know this is going to start out at 0, 1 because of that translation, and it's going to peak 3 units higher at 4 and bottom out 3 units lower at -2. So those are my key numbers, 1, 4, and -2. This is sine theta, and sine theta has a period of 2 pi, which means magic happens at regular pi and everything in between and everything in between. So let's start right here. I'm going to peak out at 4. I'm going to level out at pi where it's at 1. I'm going to bottom out at -2 and then repeat the process at 1. Okay, so let's draw a very, very, very basic curve like that, like so. Boy, did I blow it there. You get the idea. Now, let's graph some of the points that we can see. Okay, when theta is 0, I'm at 1. When theta is pi over 2, I'm at 1, 2, 3, 4. When theta is pi, I'm at 1 again. So this one right here. And when theta is 3 pi over 2, I'm at -2. So positive 2 would be right here, but -2 would be right there. Now let's look at some in-betweeners, okay? And I'll mark them with the greens. I'll mark them with green. These are my in-betweener areas, okay? So in between 0 and pi over 2, maybe I'm at like 3-ish or something like that. 3-ish or something like that, give or take. Maybe a little bit more, so 3 point something-ish. I can actually do the math, but, you know, who wants to do that? This is going to be the same 3.1-ish, 3-ish. So I'll put you here. Okay. Here, maybe you're at like a -1. So -1 would be like maybe somewhere around here. And here you're also maybe at that same -1. So it's maybe there. All right. Let's draw this out. I started out at 1. Okay, I started out at 0, 1, and I'm heading towards 2 pi, hitting that green dot along the way. So it's going to create like this circular thing that looks like that. Okay, as I go from pi over 2 to pi, I'm just making that circular thing going back to 1. Okay. As I go, and this is where it gets weird, as I go from pi to 3 pi over 2, I'm now hitting negative area going through that dot right there. And as I go from 3 pi over 2, I hit that dot right there and start at the very beginning, which is a very good place to start. So I have this weird shape thing, and I'm going to try to sketch it a little bit to make it look prettier. I have this weird shape thing where it kind of curls in. Now, why does it do that? Well, if I have what appears to be a vertical shift, I have a shape that in France is called a limaçon. I think it's spelled like that. Maybe with an A. Limaçon. Ha, ha, ha. We Americans, though, can't speak French. Or at least I can't speak French. So a lot of people would call this a cardioid. And if you're like, cardioid, oh boy. I can't spell in English or French. Now, if you're like cardioid, is there another I there? Oh, well, perfect, I think. I don't know. Who cares? This is a math class. I'm pretty sure that's how you spell cardioid. If you're thinking cardioid, well, that kind of sounds like a heart. It kind of is. As these numbers get bigger, you have like a bigger loop-looking thing. But if that number was like, kind of small or something like that, or if these numbers were smaller, you get what's called like a dimpled cardioid, which looks more like a heart. So maybe we would get something that looked like that. So that's more heart-shaped. But, the French people like to call it le maison. Oui, oui. If you are French, I really apologize.